Hello everyone. Today in this video we're going to discuss about two special kinds of triangles, and they are called equilateral triangle and isosceles triangle. So let us begin. So first of all, let us know what is an equilateral triangle. So a triangle in which all the three sides are of equal lengths is called an equilateral triangle. So you can see in the figure. So here triangle ABC is an equilateral triangle. Why? Because the length of the side AB is equal to the length of the side BC, and it is equal to the length of the side CA. That means the measurement of the lengths of all the three sides of a triangle are equal. Then in that case we can say that that triangle is an equilateral triangle. So in our case, triangle ABC is an equilateral triangle. Now one more interesting fact about equilateral triangle is that not only the sides, or you can say not only the measurement of the lengths of the three sides are equal, but as well as the measurement of the three angles of an equilateral triangle are also equal. So that is what is said in the next point, that in an equilateral triangle all the angles are of equal measure. Now we know that from the angle sum property of a triangle that the sum of the three angles of any triangle is 180 degree. Now if we divide 180 degree into three equal parts, then how much do we get? Yes, the answer is correct. We get 60 degree each. That means in an equilateral triangle, each of the angles are having a measurement of 60 degree each. Clear? Now moving on to our next special kind of a triangle, that is called isosceles triangle. So what is an isosceles triangle? A triangle in which two sides are of equal lengths is called an isosceles triangle. So as you can see in the figure, here ABC is an isosceles triangle. Why? Because here the sides AB and AC are equal. Clear? So if any two sides of a triangle are equal, then such kind of a triangle is called an isosceles triangle. Now here is also one interesting fact about isosceles triangle, that is the angle which is opposite to the equal side is also equal. So that is what is said in the next point. In an isosceles triangle, the angles which are opposite to the equal sides are equal. So in our figure we can say that since side AB and side AC are equal, so the angles which are opposite to side AB, that is angle C, and the angle which is opposite to the side AC, that is angle B, they are also equal. So we can say that angle B and angle C are equal. Clear? Now moving on to our next topic, that is sum or difference of the lengths of two sides of a triangle. So as we know that there are three sides of a triangle. Now if we take the sum of any two sides of a triangle, then what do we get, or what is its relation, or how can we compare the sum or the difference of any two sides of a triangle with that of the third side? So that is what we're going to discuss in this video now. So here the statement says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now these are kind of universal truth. You can prove it by taking any kinds of triangle. So say we have taken a triangle ABC. Now we don't know which two sides we will take. Any two sides you can take. Okay, as you wish. So whatever be the measurement of the length of any two sides, if we take their sum and compare it with the length of the third side, then we will find that in every case, for every angle, we will find that the sum of the two sides, the sum of the lengths of the two sides that we have taken will be greater than the length of the third side. Clear? So here in triangle ABC, what we have is, we will have three cases that might arise. So the first case is AB plus BC. If we take the side AB and BC, we don't know what is their length. Whatever be their length, if we take their sum, then the side which you have not considered, that is AC, which will be our third side. The side which we don't consider in the sum, that is the third side. So here the third side is what? AC. So the length, or you can say the measurement of the length of the two sides that we have considered, that is AB and BC, if we take their sum, that will be greater than the measurement of the length of the third side. Similarly, there are two other cases. The second case is if we take the side AB and AC, then which is our third side? Yes, of course, side BC. So if we take their sum, AB and AC, it will be definitely greater than the third side. And similarly, the third case arises, that is, if we take the side BC and AC, then which is the third side? Yes, AB is the third side. So their sum will be greater than the third side. Now this is, as I said, it is a universal truth, you can say, because if this criteria is not being followed, or if that whatever is written in the statement, if that is not followed, then it is not possible to draw that triangle. Every triangle has to follow that, the sum of the what is called the lengths of the two sides of a triangle. Similarly, if we take the difference of any two sides of a triangle, then that will be less than the length of the third side. It is just the opposite. And how can we say that? Now it is clearly, it can be found out from the three conditions or three cases, you can say, that we have written just now. As you can see here, if I transpose one of the side to the right hand side, what will it become? It will change its sign, it will become minus. So then we will get the difference of the two sides, and that will be lesser than the third side. So let me make it clear to you. In triangle ABC, if we take the difference of any two sides, say as I already mentioned that if we take this first case, then if I transpose this BC to the right hand side, what will become? AC minus BC, and the sign will be lesser than, so that thing only I have written less than AB. Similarly, if I take the side BC and AB, then it will be also lesser than AC. Third case is if I take AB and AC, then it will be also lesser than BC. So what I mean to say is that if we take the difference of the lengths of any two sides of a triangle, it will be lesser than the length of the third side. Clear? Now moving on to some examples. Now these examples will make the concept that we have learned just now much more clear. So see very carefully. So the first question says, is there a triangle whose sides have length 10.2 centimeter, 5.8 centimeter and 4.5 centimeter? So what we mean to say is that, is it possible to make such kind of a triangle? Yes, why not? Let us check it, if it is or not. So for that we have to suppose that the triangle is possible. So we have considered, we have assumed that yes, such kind of a triangle can be made. But how to check that can we make or not? So that's very simple. We just need to find out the sum or the difference of the lengths. So let us go with the easy one, that is the sum of the lengths. if we take the sum of the lengths of any two sides, okay, just now we have learned that the sum of the lengths of any two sides would be greater than the length of the third side. So we have to check all the three possible cases that we have learned just now. So if that satisfies, then yes, of course, we can draw that triangle. So first condition or the first case is if we take the sides 10.2 centimeter and 5.8 centimeter. So obviously it will be, their sum will be greater than 4.5 centimeter. If you add 10.2 and 5.8, that value will definitely be greater than 4.5. Similarly, if we take 5.8 centimeter and 4.5 centimeter, if we add them, that value also will be greater than 10.2 centimeter. Clear? Now the third case, if we take 4.5 centimeter and 10.2 centimeter, that also will be greater than, that value will also be greater than 5.8 centimeter. So all the three cases have been satisfied. Therefore, we can say that the triangle is possible. We can make such kind of a triangle with these kinds of length given to us. Clear? Now moving on to our next example. So here it is said that the lengths of the two sides of a triangle are 6 centimeter and 8 centimeter. Now between which two numbers can the length of the third side fall? So here we don't know what is the third side. Two sides are given to us. Now we have to find out what possible value could be the length of the third side. So let us see. Now we know that the same thing. Now we know that the sum of the lengths of the two sides of a triangle would always be greater than the length of the third side. Just now we have learned it. So in that case, what will happen? Therefore, the third side must be less than the sum of the two sides. Yes, that's definitely correct. Because as we know that if we take the sum of the two sides that is given to us, which will become ultimately 14 centimeter. So the third side has to be less than 14 centimeter according to that condition, that if we take the sum of the two sides of a triangle, then the third side is always less than that. So it has to be less than 14 centimeter. Clear? Now next thing we have learned just now, that if we take the difference of any two sides, then the third side cannot be less than that. The third side will be greater than that, in fact. So if we take the difference of the two sides, that is 8 centimeter and 6 centimeter, that is 2 centimeter. So the third side must be greater than 2 centimeter. It has to be, according to that condition. So what we came to know is that, therefore the length of the third side could be any length which is greater than 2 centimeter and less than 14 centimeter. So by these two conditions, we have come to know that the third side's length will be any value that lies between between more than 2 centimeter and less than 14 centimeter. In between that, any value can be the length of the third side. Clear? So that brings us to the end of today's video. I hope you all have understood today's video. You can go through your textbook. There are various kinds of questions given, so you can solve it using these two conditions or criteria that we have learned today about the lengths of the sides of the triangle, as well as the two different kinds of spatial triangle, that is the equilateral triangle and the isosceles triangle, as well as their interesting properties we have learned. So that's it then for today. Thank you and have a nice day.